Welcome back. This is the last and final video. I didn't meant to make three, but to cut down and not make one video very long, I figured I'll make the third one just to emphasize my point. Now, I've already walked you through how to determine a name for an alkene given a structure, but I also did given a name, I drew both the regular structure and also the line structure. So it's only logical that I actually give you a line structure and have you draw a name. The rules are essentially the same. First, you got to figure out the longest sequence of carbon that actually contains the double bond, which would be this or this. It doesn't matter. This also, just because it's sticking up doesn't mean that it's always, you can treat this as a substituent. But predominantly, most human heists would think that this would be your long chain, and that's fine. 1, 2, 3, 4, 5, and 6. Now, if you notice, I didn't say something, but you would wonder he did not say that. That's precisely right. How do I know which side to start numbering from? Like I said, you pick a location where the double bond is, look to either side. This has 2 carbons, this has 3 carbons, actually 4 carbons. So this side wins the race. So 1, 2, 3, 4, 5, 6. That's 6 carbon long chain. That's hexane. But because we're an alkene, it's hexene, right? But is that enough? The last name is not complete until you actually specify the precise location of the double bond, which is between 2 and 3. So it's 2-hexene. But then we also have a substituent, which is a 1-carbon substituent. And 1-carbon substituent is, if you have just 1 carbon, that's a methyl, right? So it's 2-methyl 2-hexene. Let's give this a shot. Same deal. You look at a double bond, first figure out the longest chain. There are a lot of options, but I clearly think this one wins the race. Again, 1, 2, 3, 4, 5, 6, and 7. Which side do you start numbering from? Again, on this side of the double bond, I have 3. On this side, I have 4. So this side wins the race. So I start numbering from there. It's between 3 and 4, and my longest chain is 7. So that's heptane, but it's an alkene, so it's heptene. And it's between 3 and 4, so it's 3-heptene. Now we have to go figure out the substituent. This is 1 dot, and so is this. So we have 2 methyl substituents, 1 in the 4th spot, 1 in the 6th spot. So 4,6 dimethyl 3-heptene. And this is the problem you're going to practice. It's just that simple. Now, you might think, could you make another video? Another video. Yeah, I can't keep on going making videos, but there will never be an end. All right? Keep in mind, there is one concept about double bonds that's very special that we haven't discussed yet, because I want to reserve that for a different context, not when we're actually naming. I think it makes sense. We will cover it pretty soon, but I do want to reserve that for something. First, I want you to get used to this, and then I'll talk to you about that special case slightly later in the course. All right, so stay tuned for the final and the last video of the nomenclature series, which will be on alkyne nomenclature.